Hello, this is the luckiest maths teacher in the world. Today we're going to use similar triangles to solve real world problems. So let's look at the first. So I am 1.8 meters tall, cast a shadow of 4 meters. At the same time, a tree casts a shadow 30 meters long, and we're going to find how tall the tree is. Now note that all of these problems involve finding a scale factor and then using that to find an unknown side in a similar triangle, just like we did last lesson. So if you're not given a diagram, let's first draw one. So I'm going to draw first a diagram of me. So there's me, 1.8 meters tall, and I cast a shadow that's 4 meters long. Of course, the sun is up here, so I can make this into a triangle. So that's the first triangle. That's the triangle of the shadow I make. Now I'm going to make another triangle with the tree in it so that I can use the properties of similar triangles. So let's draw it up again. So let's say I have a tree here. I don't know the length of it, so I'll just call it X, and it casts a shadow that is 30 meters long. And if it's at the same time of day, then the angles that the sun makes with the tree and the ground, they will be the same. And that's why these two triangles are similar. So it has to be like at the same time of day. So these triangles are similar. We don't need to prove that they're similar. All we're going to do is use this similarity to find the unknown side, the height of the tree. So I know that the scale factor, I can figure that out. It's just 30 divided by 4, because this side and this side are corresponding, which is 7.5. So to find X, I need to multiply by 7.5, because this scale factor means that I need to multiply each side in the smaller triangle by 7.5 to get their lengths in the big triangle. So to get X, I need to multiply 1.8 by 7.5. And that just gives me 13.5, so I've figured out that the tree must be 13.5 meters tall. So tree, 13.5 meters tall, and I figured that out using just similar triangles. Okay, so I'm going to do one more example. Please pause and copy this down if you need it. Alright, let's now have a go at this question here. So Andrew, measuring the height of a flagpole, places the mirror between him and the flagpole so he can see the top of the flagpole in the mirror. And the mirror is 4 meters from him, 8 meters from the flagpole, and the height to his eyes is 180 centimeters. How tall is the flagpole? This probably looks very, very confusing. But when we draw a diagram and use similar triangles, it becomes easy. Now, people actually do use this method to measure the height of things. So what they do is they'll put like a mirror. So we'll put the mirror here at a point between that person and whatever they're trying to measure the height of. So let's say this is the flagpole. So what has to happen is you have to be able to see the top of the flagpole in the mirror. So I have said in the question that this mirror is 8 meters from the flagpole and 4 meters from the actual person. So he is again 180 centimeters to eyes which look at the mirror. So if this person is standing here and this is his eyes, I'll put his eyes in red. If he can see just the top of the flagpole in the mirror, we have two similar triangles, and we can use similar triangles and the measurement scale factor to figure out the height of the flagpole. Once you got the diagram, it's very, very easy. So you've got to look at the corresponding sides. This side and this side are corresponding, because if I want to get this triangle, I need to flip this one, and then I need to enlarge it. So these two sides correspond, so the scale factor is 8 over 4, which is 2. So each side in the larger triangle is twice as long as its corresponding side in the smaller one. So I want to find this side here. So all I do is I take 180 centimeters and times it by 2, the scale factor, I get 360 centimeters or 3.6 meters. That is how tall the flagpole is. Hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.